Hey guys, welcome to the YouTube channel. Thanks for taking the time to join us. Um, I'm super excited because I recently had the chance to sit and talk with Andrew Chaffin from the Domo Data Science team. And it was super cool because we got to exchange ideas about how we talk about data analytics and bringing data science into the organizations that we're consulting and partnering with. I really hope you enjoy the highlights reel. Here we go.
Yeah, I'm Andrew Chaffin. I'm the Director of Data Science at Domo. I've been at Domo coming up on 8 years. Prior to coming to Domo, I was doing neuroscience research at Johns Hopkins, fell in love with analytics and statistics there, begged my way into Domo, been here ever since. It's been a great ride.
I did not know that about you.
Yep.
And you said you've been here like 8 years, right?
Yeah, almost 8 years.
It was really cool to talk with Andrew because he's been at the company for so long. And because of his time at Domo, he's been able to talk about both what the product has done successfully in terms of innovating expectations from BI product, but also to talk about how Domo's work in the BI space has now trickled down and started impacting expectations of data science at organizations.
What I feel like Domo did right and made Domo a big different solution in this space, just in analytics generally, is they started with the CEO or the executive in mind first, right? The
Mhm.
overall vision was have a CEO run their business from their phone, right? And then work backwards. What do we have to build in order to make that happen, right? How can we take a customer where they're starting from, wherever they're starting from, and get them to that point? And
Mhm.
I don't think we realized it at the time, but it really honed our vision, and really that's the struggle in data science today, is delivering the insights to the end user in a consumable way where they can actually drive value for the business. So I feel like data science is where analytics was 20 years ago.
That's kind of interesting. I remember when I started working at Domo, at the time, I think a lot of the messaging was that Domo wasn't designed for the analysts. Like you said, Domo was designed for the executives and leadership at the organization. And for me, as an analyst, it kind of left me confused. I'm like, well, so what are we supposed to do with it? And then now, as I hear, step into conversations about data science, I'm hearing people say, okay, data science sounds like this really cool thing. And now leaders at organizations are like, well, what do I do with data science? What is it exactly?
Yeah,
Then you go,
exactly. Even the really good data scientists are struggling to communicate the insights that they've gathered in a way that others can consume it easily, quickly, without a lot of mental brain, without a lot of mental energy exertion, if you will. And I feel like Domo helps solve that. And of course, since it's already a full stack solution, data scientists can just put their stuff into production there, which is a huge value add.
I did do my homework before I sat down with Andrew, right? So I took the time to kind of pull my network of contacts. And I was like, hey guys, I'm going to be meeting up with Andrew. What should I ask him? And so here are some of the top questions that came.
So, what is the value that data science provides? Data science can tell you why things happened rather than what happened, rather than just telling you what happened. So it's a natural step in the analytics journey, right? We can take kind of any problem. Take, for example, you're the head of HR and you are losing a certain number of employees every year. It costs the business $100,000 to recruit somebody and train them. And you are used to, just these standard reports that used to come from analytics, that you would get a report in your email. It was this, an Excel attachment telling you how many people left or were let go across which departments, and then you had to react. And it was just a standard report that you couldn't do anything with, you couldn't drill down on, you couldn't see it real time. Domo solved a lot of those problems. Now you can see things in real time. You can drill down. You can do custom reports, and you can set alerts. So it made you um, way more reactive. You could be faster in your
Mhm.
reaction. But the next natural step from there is who's going to leave, right? And why are people leaving? That's what data. Those are the questions that data science answers. Those are the natural next questions that, as a business user, you ask as you start to get real-time data, as you're starting to get alerts, as you can drill down, the question then becomes, wait, why did Andrew leave? Right? And could we
Hmm.
have known that he was going to? Could we have somehow intervened? Like, those are the actual next questions, and those are the questions that data science answer, and that's the value that it provides, if you will. And so that, that's forecasting. That's an example of forecasting. Clustering is another algorithm, but they're fundamentally just different tools to answer questions like that.
When I'm consulting with clients, one of the questions that I always ask about every dashboard, every card that we're building is, so what? What action are we trying to drive with this information? We want to get to the point where it's more than just summary statistics like average or min or max or total sales, percent of total. We ideally should get to the point where our cards are informing and changing behavior. And that's, I think, at the heart of what data science is really about.
Oh, there you go. You got the analytics journey right there.
Yeah, I got you covered. Yeah. I think it's interesting because when I do some of my Domo implementations with customers, right, they'll say, hey, Jay, what I really love to do is I'd like to automate building this report in Domo. And so like they'll give me an Excel report and they're like, can you make this table in Domo? I'm like, and the thing that I'm, in the back of my head, I'm thinking, all right, we're, automating reporting, we're making it faster, we're making the data more accessible. And then my follow-up question is always, well, cool, after we build you this big old report, what do you want to do with it?
Yeah, and what's interesting is that the reason that we're automating the reports that they already have is just simply because that's of course the first thought that they have. They don't, since they haven't ever done anything different, it's hard for them to manage it in a different world. And what's hilarious in these implementations is that you automate that report. Now all of a sudden they have all this time that they didn't have before, and they're like, oh wait, now I have these other ideas. Could we do this and this and this? It's almost like you have to clear that hurdle with them to open up the brain a little bit and free it up to imagine, if you will, right? But yeah, as you do that, like you're saying, I feel like that just naturally it organically takes your customer through this list of questions as they, on any particular business problem, right? I don't know, was there something you're gonna add there?
And I guess for those of you who haven't seen this visualization before, it was pulled from I think 2012 Gartner survey called, what is it, the Data Analytics Maturity Model. I'll put it in the links in the YouTube video. But the point is like, this visualization is certainly not new, and is definitely, I think, very common story that we see across all of our customers.
Yeah, anybody that feels like they're stuck, in baby steps, and they think that everyone else in the world is doing these really fantastic predictive problems, and it's just simply not true. Even the largest businesses are struggling with the basics. It gets complicated.
I think one of the biggest challenges with data science is as soon as you start talking about data science or probabilities or statistics, like people's eyes either glaze over or they just shut down entirely, right? Because we all had those terrible classes back in college. So for me, when I'm talking to a customer who's trying to get to that next stage in their data maturity, we try to start by just finding a relatable example. And for me, a lot of times, just something as simple as buying a house. When you go to Zillow.com or Redfin or whatever, and you just do a search for, I want to see all of the houses, you're like immediately overwhelmed. Even if as you start applying filter criteria to like what you think you want your house to be, that's pretty overwhelming to see a whole bunch of red dots.
Yeah.
And at that time, we're just doing, descriptive analytics. We're just saying, this is the space. Now you might do some aggregation and summary to say, what is the average sale price of a house? How many beds are there on average or something like that? And as you kind of do that research, you're putting together a mental model of what normal or what a reasonable price looks like. And when you get to the point where you can look at a house and you can say that's too expensive or that's a great deal compared to all of the other houses in the neighborhood, you kind of have like a little mini data science model that you're running. I don't want to say linear regression, but right, you're almost predicting what the value of this house should be based off of a set of criteria that you think are important. And then when you get to that point where you're building a short list of like the 10 houses that you want to look at or bid on, right? You've built a model that says, hey, these are the things that are important to me, and that's how I'm going to decide whether or not to buy this house.
Yeah. And I don't think that people realize, to kind of go along with your point a little bit there, I don't think that people realize that their own, I feel like you're saying, their own brains are developing data science models, right? Like I'm a sales guy fundamentally. And so if I see, a deal where a lower level employee of a company is the one investigating Domo, and they don't really seem to be able to speak the language of analytics, like I assign it like a lower score in my mind, a lower likelihood of closing. That's a model. That's a mental model, but it's essentially the same thing that data science is doing. It's looking at factors and assigning a score, right? So I don't think that people realize they kind of just inherently do that in their own brains as well. We're just trying to put it out there in statistics and validate it a little bit.
Yeah, yeah. The other example I was thinking was like fantasy football. Now I know nothing about football, but I understand there's like a draft.
Yeah,
and you decide like who's going to be on your team based off of their performance for the year.
Right.
Yeah. So like that too is in your own little way, you've built a model for like what are the characteristics of a good football player, and then how do I decide? I'm sure they have like different positions. They're like a quarterback or something.
That's good. You got one.
Nailed it. Anyway, yeah, so like fantasy football, I think, is the ultimate example of like a mini data science or stats project.
Well, and people really get into it. People actually build real serious models off of it. Yeah. So
right.
It's a great example.
What was interesting though was to say, okay, like data science, advanced analytics, that's kind of its journey on its own. But I think the bridge to getting from like pure descriptive reporting is to say, hey, instead of just giving me information like summary trends, what if you try to get to that point where you're prescribing an action? How do we get to the place where we can automate making good decisions? And again, for me, it was a case of like just finding an example that we can all relate to, like oversold flights at the airport. And the question is, how do they figure out the right number of tickets to sell to maximize profit?
Well, and this, I feel like this example kind of gets right to the heart of if I feel like I'm the one that's responsible to bring data science into an organization, how do I get started? And this is a perfect example in my mind. The way you get started, in my opinion, is you find the core model. Are the words that I use. Every business is fundamentally doing a thing at scale. For airlines, they are moving people from one place to the other at scale, right? And the way that they make money is by having as many butts in seats as possible. And so that's it. That's all you have to know in order to like know how you get started with data science. I can do an optimization model to have as many butts in seats as possible, because what we do is move people from one place to another, right? And that's how you get started, right? You can do back of the napkin math really, really easily to figure out what the return on investment would be for a core model, right? So you could say, right now we have 1,000 seats a day that don't have butts in them, right? And for every seat that we do not have a butt in, this is how much it costs our business. This is how much revenue we're losing, right? It's $10 million a year. It's $50 million a year, right? If I can build a model that has 10% more butts and seats, then I can have a $5 million return. I can have a $10 million return.
Right. That goes back to the original question, like, what is the value of data science, right? That was the first question that we talked about. We said, what is the value of doing forecasting or clustering? I think you nailed it right there. Like for every business, it's going to be slightly different. And actually, to just step through this chart in case the viewers didn't catch it, the gist of it is like 95% of your booked travelers show up, which means if you only sold if your plane fits 100 people and you sold just 100 tickets, you would have 5 empty seats. And so the question is, how many tickets above 100 should you sell? Like 1, 2, 3, 4, 5, 6, to maximize the chances that you get 100% of your revenue in terms of people and seats, but also minimize how much, and that's where we're getting here into the 7, 8, 9, and 10 tickets sold. We want to minimize the number of vouchers that for our volume.
And where
Yeah.
data science can add some extra value, if you will, is in a little bit more specificity. A flight from San Francisco to LA
Right.
probably has 85% show, whereas a flight from LA to Dubai probably has 99% show, right? You're not going to book
Right.
that ticket and not show up, right? So you can get a little bit more specific with your modeling on how many do I oversell for this particular flight on this particular day at this particular time, right?
Right.
And decrease the error, if you will.
Mm-hmm. Or in just at, and this is one of the things I love about our Domo customers who like are starting to dabble in forecasting, right? You said, you know, with data science, we can decrease the amount of error. And actually, let's take one step before that and mention the fact, hey, if you want to get into data science, maybe figure out your error, right? We have plenty of customers who
Absolutely.
like have a
Yep.
forecasting model. They're like, yeah, I predict our sales is going to be 1.25 times last, or it will be a 3-month rolling average. Whatever your method is of forecasting, you're not measuring or not comparing what you predicted yesterday versus what you actually did, not measuring that error. That might be an easy way to get.
Yeah, I think, oh man, I'm so glad you brought that up. Just to give you one real life example, we were working with a really large construction company that does big commercial projects.
Mhm.
And so they break those projects down into like sub projects, obviously. And then for each sub project, they have to estimate the cost of the project, when that project will complete, and the overall revenue that they can assign to that. And so fundamentally, the projections end up converging, right? At the beginning of the project, you say, I think it's going to take 5 months. I think it's going to cost $1 million, right? I think we're basically assigning 1.5 million to it. And then 3 months into it, you're like, oh, this is actually going to take just 2.5 more months, not realizing that you are drifting from your original projection. You do end up converging, right? And what happened with this construction company, they wanted to just automate those projections. It took a lot of man hours to create those. And as we started engaging with them, we're like, how accurate are these? They're like, oh, pretty accurate, actually, usually just a couple percent.
Yeah, 100% accuracy.
We're off a little bit, maybe a couple percent, So we went in and checked, and because they had the data, they've been really, really good about collecting all the data. So we went and checked, and they were off at the beginning when they started their projections. When they do the initial projection, they were off on average like 40%. Like it wasn't even close, right?
Right.
And they just didn't realize that they were that off because they would end up converging at the end. I think that happens way more in business than people might realize, like especially like in finance. I think you get a lot of those converging type forecasts, those types of things. Measuring that error is so critical and really kind of highlight where data science could add a lot of value. I think that's such a great point.
We've all heard of analysis paralysis. This idea, like if I have too much information, it'll be really difficult to make a decision. And so we turn to data science to kind of black box, make that decision for us. And one of the questions my friends had was like, well, yeah, but if you use a data science model, like how accurate is it going to be? Or, can I actually put money down on the accuracy of your model?
Well, what's hilarious about this is you're already putting money on it. It's not like it's a new investment.
What do you mean by that?
In data science, you're taking a process that's already happening, something you're already investing in. You're an airline that still flies planes from LA to New York. Doesn't matter if you have 100 butts in seats or 90. You're still spending that, right? And it's not an extra investment in my mind to now sell 110 tickets, right? I mean,
well, there is risk. I mean, I'm glad you brought that one up, but there is that risk that, oh, well, maybe I'll make the wrong decision.
Yeah, you still have that opportunity without data science. Like,
Yeah, if you're just relying on your gut.
I mean, you're already investing, if you want to call it that, right?
Right.
And the other thing that data science provides is accuracy measures, right? So the way that you
Yes.
build one of these models, and this is fundamentally the question that you're asking, is you you take 80% of the historical data. So if you're doing an employee churn model, which is something we talked about earlier, you're taking, let's say you had 1,000 employees that left the company over the years, right? So you take 800 of those employees and you build a model off of it. You try to figure out, why are people leaving, or how can I predict people that are going to leave? And then you keep 200 of them. This is a common way of doing it. There's lots of ways to measure accuracy, but the most common way is this holdout approach. So the other 200 employees, you hide them, if you will. And then once you've got your model built, then you run the other 200 that you held out through it. You take out the outcome measure, which might be how many months are they going to stick around. You have the model predict how many months it thinks these people are going to stick around, and then you compare those to the actuals. And then you can see, like, okay, if I had this in place before these 200 people left, how accurate would it have been? And it gives you a sense of, that accuracy. It gives you a
Yeah.
sense, it gives you the comfort of knowing this is how it performed on data that it hadn't seen before. And
Right.
so you can feel fairly confident that it's going to work the same on new data. On, when you do inference, is what's called inference, is when you take that model and you run your current employee base through it, people that haven't left.
Yeah.
Right.
I think a common one that might also be relatable would be like when you're learning to trade on the stock market, right? It's kind of
Right.
scary putting your money on the line, but if you wanted to test how good you are at predicting the future, you just apply, look at data that was from last year or 2 years ago and say, what decision would you have made at this point? And then you can actually, the answer. So then you can say, yes, you would have made money or you would have lost.
Ray Dalio's built Bridgewater, probably one of the most successful investment companies ever existed, and that's literally like that's literally what they did. Like, that's how they did it, right? They encoded their heuristics, or their mental models, into data, and then they built algorithms on them, and then they said, okay, if we had used this model over this period of time, what would we have predicted? Okay, let's compare that to what actually happened. How much money would we have made, right? And that's the test. That's how they built a ginormous multi-billion-dollar company.
We talked about that example of like United Airlines or any airline overselling flights, and they based it off of this statistic: 95% of customers show up for their flight. Well, and like you said, if we consider just the customers in Dubai, San Francisco to Dubai, or consider the customers San Francisco to LA, they might behave slightly differently. And to your point, what data science gives us, it gives you a structured way of evaluating how accurate you were, how much error you did or did not have. And it's not that you have to go with always oversell 5 tickets or always oversell 10 tickets. And then depending on how averse you are to risk, you have a slightly just oversell fewer tickets.
Yeah. I mean, if you think about it, like from your, junior high or high school days, you've got your y equals mx plus b, like, square chart, and you draw a line, right?
Yeah, a lot.
And so the prediction is literally like, okay, I put in X, what's Y, right?
Yeah.
And so you are still going to have error in your prediction. Don't get me wrong. Your predictions from data science will still have error, but they will have less error than someone just like throwing a dart, right? Hopefully. Well, and you can measure that. That's what we're saying here. You can measure that and make sure that that is true.
The last thing we talked about before Andrew had to go on with the rest of his daily life was this question of how complicated is data science and what is the maintenance cost going to be?
So Elon Musk said it best. Building a prototype is easy. Anybody can build a prototype. Putting a prototype into production is really, really, really hard.
All right, don't scare people off.
Well, the prototype is what gives you the proof, right? You don't have to, Like, that's what I was saying, like the butts and seats with American Airlines and figuring out how much this costs the business is step one. Step one is how much money are we losing with, like, how much money are we missing out on because of inefficiency, right?
Mhm.
So that's step one. Step two is building your prototype. So, okay, let's gather a whole bunch of data, right? And there's an organized way to do this that we can walk through at some point. And then let's build a prototype model, right? And the prototype will then tell you, okay, if we had something like this in production, this is how much better we would be in
Mhm.
this area of inefficiency.
Mhm.
And then you now have a really strong carrot. You can go to your whoever, you can go to the CEO, if you will, and say, look, if I built this model, it's a toy right now, it's a prototype. If we put it into production, it would save us $50 million a year. And he would
Mhm.
say, great, that sounds fantastic. How much is it going to cost us to do that? And it will be work. It is somewhat complicated to put models into production. I think it's fair to say on average, it costs a business 100 to 200 grand. That's across like actual dollars put into it as well as man hours.
Mhm.
That's for like just one kind of straightforward model. Models can get really complex, but that's a huge return on investment, right? So it is
Mhm.
complicated to put models into production. It's not hard to build prototype models. It's not hard to find use cases and estimate the impact that the model can have. It's not hard to understand how you're going to track accuracy or anything like that. Like, those are all simple things. The architecture of, as far as putting models into production, is hard. Fortunately, Domo is a really great tool to help decrease the complexity of putting things into production and monitoring them once they are.
Mhm.
But I'm not going to lie to any of your viewers out there and say that it's easy. It is hard. It's hard to put models into production.
I would also point out that not all models have to be complicated,
That's
and
fair.
not all model. I mean, obviously you're the professional in the thing, but like coming back to our stock trading example, like if you said, I'm going to place a bet that the behavior in the stock market today will be the same behavior as yesterday, right? That is a model that you can apply. That's relatively easy. Now, how
That's
good
fair.
or bad that model is, totally different question. And you could say, oh, well, I'm going to assume that the behavior today will be the average of yesterday and the day before yesterday, which is also a relatively simple model. And you can have like all sorts of like 5, 10 different permutations of how you're going to base how you're going to guess today's behavior based off of what happened in the past. Now, which one's the best one? How can you get the best result, right? That can become, I think, increasingly more complex.
Yeah, that's totally fair. It's a good call out. All right, Jay, I apologize. I'm 3 minutes late to my next meeting. I got to run, but we
All
can pick
right,
this
Andrew,
up
this
whenever
has
you
been
want.
so much fun. Thank you so much.
No problem. See you.
Catch you later. Bye. Have it, guys. Data science demystified, both in the context of Domo and like how our customers are using or integrating data science into their business processes, but also kind of like as a general holistic approach to how you can get started on your data analytics maturity. I hope you found this useful, and if you did, please leave a like or subscribe to the channel. We'll definitely use your feedback as we kind of shape the next webinar. So thanks so much for joining. We'll catch you guys another time.